Hi everyone, ladies and gentlemen. Let me introduce myself. I am Syamsul Zaibon, currently serve as Associate Professor of Creative Media at the School of Creative Industry Management and Performing Arts, Universiti Utara, Malaysia, UUM. My research focuses on multimedia and mobile applications, game-based learning, comics for learning, and edutainment. I am also one of the Senior Research Fellow from the Institute of Creative Industry Management and Sustainable Culture, ICIMSC UUM. It is an honor for me and my colleague, Dr. Emram Yunus, to deliver our research presentation today. The title is The Effectiveness of Game-Based Learning Application Integrated with Computational Thinking Concept for Improving Students' Problem-Solving Skills. In my presentation, I will cover four main points. First, introduction to computational thinking, game-based learning, and problem-solving skills. Second, research methodology on procedure, instrument, and data analysis. Third, findings of the research. And lastly, discussion and conclusion, where I will conclude the results and discuss the research contribution. So that would be the overall structure of my presentation. Now let's move on to the first point. The introduction about the computational thinking. Generally, computational thinking is not limited to computer scientists or professional programmers only. When CT are linked with critical thinking and computer technology capabilities, computational thinking can help all of us, including teachers, students, in thinking of new ways to understand and explain elements of human daily life and how problems can be solved more effectively. For examples, performing tasks we need to do today, avoiding accident by identifying hazard characteristic, using a diary to organize tasks according to daily time or hours, or creating a set of instructions for colleagues, and so on. All of these tasks need kind of computational thinking. Studies show that this computational thinking can be integrated in various learning methods, and one of them is game-based learning, GBL, which can be implemented during teaching and learning, whether as technology or learning media. In addition, GBL is also seen to have a positive effects on students' problem-solving skills and knowledge acquisition while increasing their motivation and involvement during learning. Integrating CT, this computational thinking, in the GBL approach means applying the CT concepts such as abstraction, algorithm, decomposition, automation, and evaluation through digital games with the aim of improving students' problem-solving skills. Based on the previous studies, there is lack of research that describe the CT concept integrated in GBL for subjects in schools that can improve problem-solving skills among primary school children. Most researchers agree on the importance of understanding the concept of CT for use in education for the 21st century learning. In relation to this, several approaches have been proposed to ensure that students comprehend the fundamental concept of CT, including design solution to problem, implement design, test and debug, model, run simulation, carry out system analysis, and etc. For example, in Table 1, studies have been conducted which describe how the CT concept were applied in their respective curricula and fields. For example, Turkey, Fogli, and Malaysia applied the CT concept using collaborative gameplay to develop CT skills among secondary school children. CT in education has significant potential in improving student problem skills at many education levels. In this regard, in Malaysian context, the Ministry of Higher Education of Malaysia has outlined clear objectives in the introduction of CT starting in 2017. Among the objectives are assisting teachers to better guide their students in finding new solution to problems, assisting teachers to improve teaching and learning. Therefore, teachers can use any new solution by integrating CT, computational thinking, to improve teaching and learning practices. As an example, through game-based learning. GBL or game-based learning is another essential approach for the 21st century learning, where it promotes learning motivation and enhance problem-solving skill among students. Integrating CT concept in GBL would provide more effective learning environment to them. The study by Kazimolu et al. States that they have developed a game framework that allows students to compete some skills during a gameplay. The finding of this study clearly indicated that there is a positive relationship when GBL and CT are integrated. The skills are creating and using algorithm to solve specific problem, evaluating an algorithm by determining the appropriate criteria, applying the CT method to the problem, and etc. Now, next to the introduction about the problem-solving skills. Every problem needs to be solved in most effective way to achieve the best results. Similarly to learning environment, where students need to have problem-solving skill for their daily life. According to Mumtaza and Husna, they define problem-solving as an effort to find alternative ideas and measures to overcome the existing obstacles to achieve a goal through complex and complicated mental process. This skill can increase self-confidence and preparedness of students for current and future life challenges. Figure 1 shows the example on the problem-solving skill, the process of problem-solving, starting from identifying problem, then until they make the decision and take the action. If I can conclude, the problem-solving skill is really related with computational thinking, where CT is an effective thinking process in solving student problem, and has a significant influences on their academics. Therefore, this study will test the effectiveness of GBL application for CT in improving student problem-solving skill. Next, let me explain the methodology that has been followed for this research. At the initial stage of this study, a basic computer science subject teacher was assigned in assisting the experimental procedure and was briefed on the procedure to ensure that he has a clear understanding how the process taken place. As seen in figure 2, two groups of students were assigned according to their classes, either as the experimental group, total is 24, or the control group, total is 25. At first, the research started with students in both groups answering pre-tests for measuring problem-solving skill, which took 75 minutes duration. Secondly, students in control group learn about the problem-solving for programming topic, which was identical topic for both groups from the teacher using the problem-solving GBL as a learning tool. This GBL application was developed traditionally using problem-solving theory. Then students in experimental group took the same learning session from the same teacher using the CTGBL. CTGBL is application developed specifically using the GBL design model integrated with CT concept. The experiment was conducted for 4 days, in which 1 hour was allocated for each session for both groups. Students from both groups was supervised by the teacher, and the researcher acted as a facilitator who assisted in technical matters. Finally, the learning session were completed. The students were asked to answer the post-test question, which held in 75 minutes, and the result of post-test were recorded. The effectiveness assessment is actually measured through the analysis of student achievement through their marks in the pre-test and post-test question sets, which were adopted from the OECD's Program for International Student Assessment, PISA, on the problem-solving skills. Okay, let us see the finding of the experimental study. The main objective of this study is to assess the effectiveness of the computational thinking GBL compared to the problem-solving GBL application in improving student problem-solving skills. Firstly, table 3 shows the mean of pre-test score of the control group and the experimental group, while in the table 4 illustrate the living test result to test the sample have the equal variances. The result from the living test, the insignificant living test results in table 4 prove that the pre-test score of the both group are homogeneous and suitable for making assumption of population homogeneity of variances. So next, the analysis proceed to the comparison of pre and post-test scores between control and experimental group. The finding on the descriptive analysis on the test score of the experimental and control group in table sheet 6 show that there were differences in the mean values and the pre and post-test scores. The mean value of the experimental group was found to have increased to 66.38 in the post-test from 43.46 in the pre-test, a difference of 22.74 in mean value. The increase is enormous compared to the mean value of the control group. Next, to achieve the main objective of the research, whether there is significant difference in mean of student scores in problem solving between group of CT GBL and PS GBL, the ANCOVA analysis was performed to test the research hypothesis, where the hypothesis aims to identify whether there is significant difference in student achievement between the control group and experimental group in post-test scores by making pre-test scores as covariates. Prior to conducting the ANCOVA analysis, the living test has been performed and it was verified the assumption of homogeneity of variances have been met. Then the ANCOVA analysis was conducted after that. In table 4 shows that the adjusted mean for the experimental group mean 71.75 was different and significantly higher compared to the control group with mean value 60.24. This analysis shows that the achievement of students in the experimental group was performed better than the control group in the post-test after the covariate effect was considered. Next, after the ANCOVA analysis was conducted, the result shows in table 9 indicate the significant value and the value of partial eta squared at 0.67 values. Based on these findings, students that having learned with the computational thinking GBL application have affected or contributed 67% to student achievement. In addition, the result also revealed that both groups on post-test scores are significantly different when the effect of their pre-test scores was excluded. This significant difference in mean allows the researcher to accept the hypothesis of this study that the mean of student achievement in problem-solving skill using GBL for computational thinking is significantly higher than the problem-solving GBL application. So this finding shows the effectiveness of the CT-GBL compared to the PS-GBL improving students' problem skills. So as a conclusion, the objective of this research is to determine the effectiveness of game-based learning application integrated with computational thinking concept for improving student problem skills. To determine the level of problem solving skill among students, they were assessed based on the pre and post test scores and grouped into control or experimental group. There are two types of GBL application used in this experiment, namely CT-GBL for the experimental group and PS-GBL for the control group. The data were analyzed using ANCOVA and the pretest scores as the covariate. The results showed that the mean for the post-test score of the experimental group were significantly higher than the control group. According to the finding, also indicated that the computational thinking GBL has affected or contributed to the student achievement, which is about 67% in problem solving skills. Although there has been some research done in field of this computational thinking and GBL, game-based learning, there's a lack or no further studies that integrate these two fields in one model or one framework. Therefore, this research can contribute to new discoveries to the knowledge and also help students to improve for problem solving skills. It will also serve as a guideline. The research will also serve as a guideline for teachers and government to develop more effective educational materials that can contribute to the national education agenda for the 21st century learning. That's all for my presentation on my research. Thank you very much.